We are going to solve 9702 winter 23 question paper 1-1. Okay, so let's begin with this paper. In the first question it says, what is a reasonable estimate for the cross sectional area of a wire in a paper clip? Okay, so let's look at each of them one by one. It's talking about individual reasonable estimate of the cross sectional area, right? So to get a reasonable estimate of cross sectional area, let's find out what the radius will be and let's think what the probable would have been. Okay, so in the first option we can see that it says 1 into 10 to the power negative 3 meter square. Let me change my pen. Okay, yeah, fine. Okay, so let's we know that a cross sectional area equals to pi d square over 4. So let's convert each of them into the diameter. Okay, so if I convert this into diameter, how am I going to do is pi d square over 4 is going to be equal to 1 into 10 to the power negative 3, from which I can find out the diameter to be 1 into 10 to the power negative 3 into 4 divided by pi, and the square root of the answer gives us a diameter of 0.0356 meter, which is roughly equals to 3.56 centimeters. So we know that a paper clip cannot have a diameter of such big 3.56 centimeters, so option number A can be cancelled out. We can do the same thing for option number B. In the option number B, we can apply the same formula and then we can convert it into the centimeters by doing the same thing. It's going to be 8 into 10 to the power negative 5, which means the diameter is going to be the square root of 8 into 10 to the power negative 5 into 4 divided by pi into 100 gives us roughly 1 centimeter, and we know that it's not that big as well, right? So option number B is also incorrect. Let's look at option number C. If we do the same thing for option number C, we are going to get a diameter of 8 into 10 to the power negative 7 divided by pi multiplied by 4, and then take out the square root and then multiplied by 100 to find out in centimeter. It gives us roughly for its diameter is going to be 0.1 centimeter. Okay, so 0.1 centimeter seems quite reasonable, so this must be our answer. Let's look at option number D for confirmation. Okay, in option number D, if we find the diameter, we are going to get 1 10 to the power negative 9 into 4 divided by pi and then multiplied by 100. So we are going to get 3 into 10 to the power negative 3 centimeter. Okay, so we know that it is not that small as well, so from this estimation we can conclude that option number C is going to be the correct answer. Let's erase all of this, and then option number C is going to be the correct answer. Let's look at question number 2. It says, which quantity is not an SI based quantity? Okay, it's taking not an SI based quantity. We know that charge is not an SI based quantity. You know that I equals to Q by T. We know I is a base quantity but Q is not a base quantity, right? Current is a base quantity but charge is not a quantity, so this might be our answer. Mass is a SI base quantity, it is a fundamental quantity. Temperature is also a SI base quantity, and time is also an SI base quantity. Okay, we know that there are 7 base quantities, and option number A is not the one, so yeah. Let's look at question number 3. A student determines the acceleration of free fall by using a small metal ball S1. When switch S is opened, the ball is released from an electromagnet and an electric timer is started. Okay, the ball then falls vertically downwards, the timer stops and the ball hits a trapdoor. Okay, the student measures a distance PQ between the electromagnet and the trapdoor. This distance and the reading on the timer are then used to calculate the acceleration of the free fall. Which statement about errors in the experiment is correct? So before we begin the question, I want you all to remember this formula. If you do not know, G equals to 2H over T2 square minus T1 square. This formula was particularly derived whenever we are talking about the experimental verification of the acceleration of free fall. Okay, that is one of the experimental verifications that is included in the AS syllabus, so it is always better to know this formula. Okay? Otherwise it is going to take 10 minutes or about to know this formula, and this formula is frequently used in such type of questions for the ease of solving. Okay, the random error can be reduced by adding the diameter of the ball to distance PQ. Okay, so we need to tell which statement about the errors in the statement is correct. Basically we are calculating the acceleration of free fall, right? The random error can be reduced by adding the diameter of the ball to the distance PQ. So basically what happens is we start the timer whenever it's over here, and then when the ball is falling, the ball hits over here, right? So what is actually happening is we are actually measuring this distance, this timing, right? We are measuring this time, but we should have had measured actually the distance from here to here, which means that if we add the diameter to the distance, then the random error can be reduced. This is actually incorrect, okay, because the answer is inconsistently going to be somewhat lesser than the diameter. So if we add the diameter, then we are going to reduce the systematic error, okay, not the random error. So because of this reason, option number A is not correct. The random error can be reduced by subtracting the diameter. Once again, this is also an incorrect thing, because as I explained, we should have measured the time between this and this, so that would have been better. So this is also incorrect. The systematic error can be reduced by adding the diameter of the ball to the distance PQ. The systematic error can be reduced by adding the diameter of the ball to the distance PQ. That is actually incorrect as well, okay, because since we are measuring timing for this distance, it is better if we measure the distance for this as well, right? So what we need to do is, for this question, the systematic error can be reduced by subtracting the diameter of the ball from the distance PQ. Yeah, this is the correct answer, because we have measured distance PQ, but we should be actually measuring this distance, right? We should be measuring distance x, but we are measuring the distance PQ, which should be subtracted to find out the x. And when we divide the time taken for the ball to fall with the time measured, we are going to get the answer, right? So option number D is the correct answer. I hope you understand. Let's look at the other question. Okay, the diagram shows two coplanar forces. Force R is given by R equals to Q minus P, which diagram represents R. Okay, so R is given by Q minus P, so let's rewrite it as Q equals to P plus R. Okay, which means Q is going to be equal to P plus R, means Q is going to be something like this. Let's look at not this, let's look at this only. Let's Q is drawn in this direction, and if P is in this direction, then negative P is going to be in that direction. So I can draw negative P like this, and I should be drawing them in a head to tail position, right? So let's move this Q over here, which means that our resultant is going to be in this direction, which means that option number A is going to be the correct answer, right? For question number 4, wait a minute, let me do this question once again. P is in this direction, which means negative P is going to be in this direction, and Q is going to be in that direction. Okay, so we need to consider the magnitude as well. Okay, so if you draw it to scale, the question has said drawn to scale, right? So if you do not draw to scale, then you might be confused in whether option number A is answer or option number C is the answer. Okay, so let me measure the length, and then after let me draw it to scale. Okay, so the length of Q will be this, so let me, not this, wait a minute, it's going to be roughly this length. Let me copy this and move it over here. Okay, this is going to be the exact length of Q, and the length of P is going to be this, so the length of negative P is going to be this. Let me move this as well. It's going to be like this, which means that our resultant is going to be somewhat in this direction, right? Exactly this length, which means option number C is going to be the correct answer. Okay, always remember, whenever a question is saying drawn to scale, you need to draw to scale and then after check what the actual thing is going to be. Okay, otherwise you are most probably going to get a wrong answer. Let's look at question number 5. It says a parachutist falls from a stationary balloon at time t equals to 0. The VT graph for the parachutist from time t equals to 0 until the time when he is just above the ground is shown. Okay, the time this is just above the ground. Okay, which graph best shows the variation with time of the acceleration of the parachutist? Okay, so we need to find out the acceleration with time graph, and we have been given the VT graph, right? So yeah, we can draw that. Let me make this eraser small, and then after let's discuss what is going to happen. Okay, what is going to happen is, initially the velocity is going like this, right? What is happening is, so initially it has some this tangent, but it has a decreasing slope, right? I think you can understand this. It has basically a decreasing slope, which means that acceleration is going to be linear but decreasing up until this point, right? Which means acceleration is going to be decreasing, not necessarily linear. So up until p the acceleration is going to be decreasing, and then after, since we reach a terminal velocity over here, which means that the acceleration due to gravity is going to be 0 between p and q. Okay, it's going to be decreasing, and then after it's going to be 0 between this and this point. And then for motion between q and r, we can see that the tangent is actually suddenly decreasing once again to a new constant velocity, right? Which means that the graph is going to go towards the negative direction as well, which means that we can already cancel out option number C and D because it's not going to have this type of curve. Okay, basically what is happening between the motion between q and r is the tangent is again decreasing. Okay, the tangent, if we draw, then it's going to go something like this. You can see that the tangent is decreasing towards the slope 0, right? Basically, since there is a very sharp change, and the sharp change is greater than actually this one, so we can say that it's not going to be the same length as that. Okay, because there is basically going to be a sudden deceleration because the change in time is actually lesser than this and this. So we can say that option number A is not the correct answer and option number B is the correct answer. That's just because the time taken for the change in velocity was small for q and r, and we know acceleration is inversely proportional to time taken, right? Change in time. So because of this reason, the acceleration is not going to be of the same deceleration is not going to be the same magnitude. Basically it's going to be some bigger magnitude. And let's look at question number 6. In question number, it says a projectile is fired from point P with a velocity v at an angle theta to the horizontal. It lands at point Q, a horizontal distance r from P at a time t. The acceleration of free fall is g. Air resistance is negligible. Which equation is correct? Okay, so we have been given some equations, and we need to find out which equation is correct. Okay, the v is the resultant velocity, and then after which means that the horizontal velocity is going to be v cos theta, right? It's going to be v cos theta, and the distance is given to us as r. We know that since this is an average velocity, the velocity is not going to change in the horizontal direction. We can say that v cos theta is going to be equal to displacement over time taken, right? Since the time taken is t and the displacement is r for the body, so can we say that r equals to vt cos theta? Yeah, vt cos theta, right? Which means that option number 6, option number A is the correct answer, right? Basically you can try them out by taking the vertical velocity. Okay, let me explain to you why these are incorrect options. Basically this is going to be v sin theta, and you know the acceleration is going to be in the downward direction, so we can take it as negative g, which means that we have the initial velocity and we have the displacement also, right? So no, we do not have the displacement for this motion, for the vertical motion. For the vertical motion, the displacement is going to be in some this direction. But what do we know is what we can do is it's talking about. Okay, so these are also incorrect because the vertical displacement is not in terms of r. Okay, if we take the vertical formula, then this is not going to be whatsoever, so C and D can also be cancelled out. Let's look at question number 7. A man stands in a lift that is accelerating vertically downwards. Which statement describes the force exerted by the man on the floor? Okay, the lift is accelerating vertically downwards and the man is standing on a lift, right? For option question number 7, let's look at all of the options. Okay, the force exerted by the man on the floor, it is equals to the weight of the man. Okay, I don't think this is a correct answer because you can imagine a free falling body. Okay, for a free falling body, what happens is a body is freely falling under due to some acceleration, that is actually acceleration due to gravity. For a free falling body, okay, I'm just explaining using an example. So whenever a free falling body is there, you can notice that the body feels like it has no weight. Okay, there is some apparent the apparent weight is actually becomes 0. Apparent weight is 0 whenever a body is freely falling. Okay, you can practically try this out in your laboratory with some Newton meter, and then after attaching a mass. Okay, when you drop it for a certain time during the free fall, the meter is going to show 0. Okay, so we cannot say that the force exerted by the man on the floor is equal to the weight of the man, because actually the apparent weight is going to be 0 and the man is actually applying some normal contact force, right? So we cannot say this is the correct answer. It is greater than the force exerted by the floor on the man. Greater than the force exerted by the floor on the man. Since the force exerted by the floor on the man is the same as the force that is applied by man on the floor according to Newton's third law of motion, so we can say that option number B is also not going to be the correct answer. It is less than the force exerted by the floor on the man. It is less than the force exerted by the floor on the man. Basically, we talked that according to Newton's third law of motion, this is not going to be the correct answer. Option number D says that it is less than the weight of the man. It is less than the weight of the man. Okay. This is actually a correct answer because apparent weight is equal to 0, but the actual weight of the man is certainly there, right? So which means that it is going to be less than the weight of the man because how do I explain this? It's going to be less than the weight of the man because you can imagine two bodies which are falling parallelly. Okay, basically since they are falling together, the force that is exerted is going to be less, right? Because both of them are contacting with only slight force. So we can say that option number D is going to be the correct answer for question number 7. Let's look at question number 8. A ball of mass 200 grams is thrown horizontally with a speed of 20 meter per second. Okay, so it's thrown horizontally against a vertical wall. Okay, it's a 20 meter per second force speed, and the mass is 200 grams. A ball is in contact with wall for a time of 0.1 second before rebounding back along its original path with a speed of 10 meter per second. So finally it strikes the wall, and then after it returns with a speed of 10 meter per second. And the mass is unchanged, right? 200 grams. So we need to find out what is the average force exerted by the wall on the ball during the collision. So you know that force equals to rate of change of momentum with respect to time, right? The time taken for the change in momentum is given to us as 0.1 second, and we can divide it by time, which means and the change in momentum is like the final momentum minus the initial momentum, right? So let's make a convention. We are going to take this direction as positive and this direction as negative, which means that the initial velocity of 20 meter per second is going to be positive, but the final velocity of 10 meter per second is actually going to be negative because it is in the opposite direction. So we can say that the mass is going to be the same, right? So I can take 200 grams as common. We need to convert it into kilograms, right? So gram is converted into kilograms, and the final velocity is the negative 10 meter per second, and then the initial velocity is 20 meter per second, right? And then after, if I divide it by time, and then after if I put this in my calculator, I am to get roughly 200 into 10 to the power negative 3 negative 10 negative 20 and divided by 10. Okay, so we are going to get negative 0.6 newtons. The time is given 0.1. I'm sorry, I typed mistake in my calculator. If I divide it by 0.1, then we are going to get negative 60 newtons. Okay, actually negative 60 newtons, which means option number B is going to be the correct answer. Okay, is this clear? Let's look at question number 9. In an experiment, a metal ball is dropped into a viscous liquid. The terminal velocity of the ball in the liquid is measured. The experiment is repeated 4 times. For each experiment, a change is made to one of the following: the density of the metal of the ball, the height from which the ball is dropped, the density of the liquid, and the depth of the liquid. Okay, which two changes separately affect the terminal velocity of the ball in the liquid? Okay, so what happens is for the terminal velocity, for a ball to reach terminal velocity, what should happen is if a ball is falling under a liquid, there are going to be two forces. Okay, the weight is going to act downwards, and the upthrust is going to act upwards, and then the drag force is going to act upwards, right? Basically the difference between the weight and upthrust, let's say this is going to be the resultant force. Okay, let's, for the sake of simplicity, because both of them are going to be constant, so let's say the resultant force becomes downwards, right? Because weight minus upthrust, let's take it as R. And then what happens is the ball is moving downwards, there is going to be certain acceleration, due to which the drag force is going to increase certainly, right? There are made several changes. The density of the metal of the ball, basically the density changes the weight, which means that the R is increased, right? Since R is increased, the downward force is increased, which means that it is going to take a longer time to reach terminal velocity, which means that option number 1 is going to be affecting it, right? Option number 1 is going to be affecting it. Let's look at option number 2, the height from which the ball is dropped. The height from which the ball is dropped, okay. The height from which the ball is dropped does not affect the weight of the ball whatsoever. So actually this does not affect, okay. The height from which the ball is dropped is not going to be affecting it, because the R force is going to be constant, because the weight is not going to change and the upthrust is not going to change whatsoever by the change in height from which the ball is dropped, right? So yeah, it's not going to affect it. And the density of the liquid is actually going to affect it, okay, because when upthrust is changed, then the resultant force is going to be changing, right? So since the resultant force has now decreased, which means that it is going to reach terminal velocity faster, so density of the liquid affects actually, right? Let's look at option number 4, the depth of the liquid. The depth of the liquid is not going to change, okay, because even if you drop a ball in the Mariana Trench or your natural pond, the time taken for the terminal velocity is not going to change, right? It does not depend upon the high depth of the liquid, so it's not the correct answer. So for question number 9, option number B is going to be the correct answer, okay. Let's look at question number 10. Two objects move towards each other along the streamline. After colliding, the two objects stick together and are stationary, okay. Which statement must be correct? So basically, two objects move towards each other along the same straight line. The two objects stick together and are stationary, right? So they become stationary, which means that you know that initial momentum is going to be equal to final momentum, right? So according to the law of conservation of momentum, initial momentum must be equal to final momentum. So if this has momentum p1 and this has momentum p2, then basically the sum of initial momentum is going to be given by p1 minus p2, right? Because it has a momentum in the rightward direction and it has a momentum in the leftward direction. So basically the final momentum is given to us is 0, because the ball is stationary, which means that we can conclude that the final momentum, the momentum of this and this was equal but in opposite direction, right? So it is talking about which statement must be correct. The total kinetic energy of the two objects does not change during the collision. You know that basically basically you know that this whenever two objects stick together and are stationary, this is talking about inelastic collision, right? In inelastic collision, only momentum is conserved. Only the momentum is conserved, but the kinetic energy is not conserved, right? Kinetic energy is conserved only in elastic collision, okay. Kinetic energy is not conserved, which means that the total kinetic energy of two objects does not change during the collision. This is an incorrect statement, okay. If the kinetic energy had been changed, then it would have been an elastic collision, and then after they would not stick together, okay. So this is not the correct option. Option number B says the total momentum of the two objects before the collision is 0. The total momentum of the two objects, okay, it should be equal to 0, okay, because in inelastic collision the momentum is conserved and the final momentum is given to us as stationary, which means that initial momentum must also be equal to 0, right? So option number C says that two objects have equal mass. This is not necessary, okay. It might have a greater mass and it might have some different velocity and it might have some different velocity, but the product of them are actually equal, okay. Those individually are not equal. Basically 6 and 6 sorry, you can say that 12 and 12 are going to be equal, but 4 into 3 and 6 into 2 are not equal, right? Basically this is what the question is asking to us. The two objects do not have an equal mass, not necessary, but they might have as well. The two objects have the same speed before the collision. The same reason, it's not same every time, okay. The momentum is only the same. The velocity might not be. It might be, but it might not be as well. So option number B is the correct answer for question number 10. Question number 11 says a minimum torque of 20 Newton meter must be applied to the lid of a jar for it to open. The radius is given to us is 4 centimeter. What is the minimum force that must act on each side of the liquid in order to open it? So we know that the formula for torque equals to force into the distance between them, right? Force into distance between them. So the torque is given to us as 20 Newton meter, and we need to find out the force, and the radius is 4 centimeter, means that this whole distance is going to be 8 centimeters. So let's convert it into meters. The distance between these two forces is what is used in this formula for the torque. So what we can say it, force is going to be equal to 20 divided by 8 into 100, okay. It's going to be 2000 divided by 8. 2000 divided by 8 is just equal to 250 newtons, okay, which means that for question number 11, option number C is going to be the correct answer. Let's look at question number 2. Well, a uniform bar of length L and weight W rests horizontally on two supports X and Y. Okay, support X exerts a vertical force Rx at a distance of L by 6 from one end. Okay, and support Y exerts a vertical force Ry when the bar is in equilibrium. What is the ratio of Rx over Ry? Okay, so for this question, let's take W as the pivot, because W is the force that is ignored in this ratio. Okay, so let's take this as the pivot and the bar as a length of L, which means that from the midpoint this overall length is going to be L over 2, and which means that I can find out this length as L over 2 minus L over 6, which is going to be 1 by 2 minus 1 by 6 gives us L over 2 minus L over 6 gives us, and this length is going to be L over 3, which means that the distance of the force Rx is given as L by 3, and then after for Ry the distance is simply L over 2, right? So we need to find out the ratio of Rx by Ry. Since the bar is in equilibrium, we can say that the anti-clockwise moment is going to be equal to clockwise moment, right? So this means Rx L by 3 is going to be equal to Ry L over 2. The L and L are going to be cancelled out. So Rx by Ry is going to be equal to 3 over 2. Okay, so option number A is going to be the correct answer for question number 12. Let's look at some other questions also. A type of firework is made by connecting two rockets facing in opposite direction. The rod is attached to a frictional pivot so that the fire can rotate vertical as WW. The pivot exerts a force R on the rod at equal to in opposite W. Each rocket exerts a force magnitude F on the rod at a perpendicular distance T. The forces exerted by rockets are always in opposite direction, which statement is correct? It's talking that which statement is correct. Okay, option number A says the firework is in equilibrium because the resultant force acting on it is zero. This is not correct. Okay, it is not in equilibrium because torques are acting in opposite direction, which means that the body is going to be rotating in this direction. Okay, is this clear? The body is going to be rotating in this direction, which means that the net moment is not equal to zero, which means if it is in equilibrium, it's only correct option. The body is not going to be in equilibrium. Okay, because the resultant force acting on it is not zero. The resultant force is actually zero because the upward force is equal to the downward force. This is not the correct option because the resultant torque acting on it is not zero. Okay, this is actually what I talked previously, which means option number D is going to be the correct answer for question number 13. Yeah, let's look at question number 14. It says what is the ratio of density of oil over density of water? Let's look at the information. An object of weight W is suspended from a Newton meter. When the object is completely immersed, the Newton meter reads P. Okay, in water. When the object is completely immersed in oil, the Newton meter reads Q. What is the ratio of density of oil over density of water? Okay, so the Newton meter is measuring basically the difference between the weight acting vertically downwards and the upthrust that is provided by the liquid. Okay, which means that the Newton meter is showing us the difference between P minus W minus Cu. Okay, so basically it's showing us, the Newton meter is showing us the value of P plus W, P minus W plus Cu, and then what we can say is this is actually what the value is shown by the Newton meter. No, actually the P is going to be equal to, okay, my bad. Okay, so P is going to be equal to weight minus upthrust, and for here Q is going to be equal to weight minus upthrust. Okay, you know that the density of water is greater than density of oil. So what we can say is for the ratio of density of oil over density of water, it's going to be P minus W, W minus P is going to be equal to upthrust, right? Upthrust of water specifically and upthrust of oil specifically. So upthrust of water is given by rho g V, right? The rho of water, and the upthrust of oil is equals to W minus Q, which means the upthrust of oil is given by rho of oil into G into V, right? And which means that the rho of water is going to be W minus P over GV, and the rho of oil is going to be W minus Q over GV. And then we need to find out the ratio of density of oil over density of water, which means we need to find rho O by rho W, W minus Q over GV divided by W minus P over GV, right? This and this are going to cancel out. So the correct option is going to be W minus Q over W minus P. Option number D is going to be the correct answer for question number 14. Yeah. For question number 15, it says a crate of mass 50 kg is pushed a distance of 6 meter along a horizontal surface. A crate of mass 50 kg is pushed a distance along a horizontal surface against a constant resistive force of 70 Newton. The crate moves at a constant speed, okay, which means that the force applied is actually equal to 70 newtons, okay. It is then lifted at a constant speed through a vertical distance of 1.2 meter onto the back of a lorry. It is then lifted at a constant speed upwards as well. What is the total work done in this process? What is happening is basically there are two works done, okay. Basically work done against friction is done as well, and then after the work done against gravity as well. So we need to add these two works, okay. Basically the work done against friction is going to be equal to, since the body was moving at a constant speed, which means that the force was actually equal to resistive force, because if it was more, then it will not be moving at a constant speed, right? So we can say that the work done against friction is equal to 70 into the mass into the force into displacement, right? Force applied is 70 newtons and the displacement is 6 meters, right? So it's going to be 70 into 6, and then now we need to add the work done against gravity as well, right? The work done against gravity is mgh. So I need to add the mass times the acceleration due to gravity times the height is 1.2 meters. So if I put this in my calculator, I am going to get 70 into 6 plus 50 into 9.81 into 1.2 meters. I am going to get 1008.6 which is basically 1000 joules, okay. So option number D is the correct answer for question number 15. For question number 16, the input power to a television is P in. The useful sound and light power emitted by the television is P out, okay. Efficiency is given by power output over power input, right? The input power is P in, the useful sound and light power emitted by television is P out, okay. So the ratio is going to be P out over P in, so option number A is going to be the correct answer. A builder is holding a brick of mass 3000 grams, drops the brick on his foot, okay. What is the reasonable estimate of the change in GPE energy on the brick, okay. mg delta S gives us the change in gravitational potential energy. Mass is given as 3000 grams, which means 3 kilograms. Then acceleration due to gravity is 9.81. And then the height change, it's talking about reasonable estimate, okay. A builder, the average height of a person might be 1.7 to 1.8 meter. Let's take it as 1.8 meter, okay. Assume that he's tall. He's a tall guy. 3 into 9.81 into 1.8, the change in gravitational potential energy is given to us as wait a minute, 3000 grams equals to 3 kilograms, right? Yeah, 3 kilograms into 9.81, and it's 1.8 meters, and this is going to be giving us the work done against gravity, right? A builder holding a brick of mass, okay. So we got a reasonable estimate of 52.974 joules. For question number 17, the closest answer to 52 is going to be 30 joules, okay. It's talking about estimate because we have taken a lot of estimate, okay. We have taken the height to be 1.8 meter. He might not be that tall. Let's say according to this question, how tall is he actually? 30 divided by 3 into 9.81. The question assumes him to be 1.01 meter tall. That's just too short, okay. Wait a minute, how tall is that? 1 meter in feet. 1 meter, okay. So he's just 3.2 feet, okay. He's really tall, really short. For question number 18, an elastic cord of one stretch total length 16 cm and cross section like this is held by two smooth pins in a distance this apart. The cord obeys Hooke's law. A load of mass this is suspended, okay. So what is the Young modulus of the cord material? This is what we need to find, okay. Okay, so the Young modulus is given to us as stress over strain. Stress is force over area, cross sectional area, and then the strain is going to be, if we divide it by strain, then the strain is delta x over x, right? The mass is 0.4 kg, which is acting downwards, but we need to take the force that is acting on the cord, okay, not the force that is in some other direction. We need to basically take the tensile force of the cord. So basically this cord is holding this thing apart, right? So basically we need to find out what this tension is going to be. Let's say this is tension and this angle is going to be 30 degrees, right, by symmetry, and then which means that this length is also going to be 8 centimeters. So the mass is 0.4 kg, means the weight is given to us as the weight is going to be mass into acceleration due to gravity. 0.4 into 9.81 gives us 3.924 newtons downwards. So we can find out the tension. The tension in the two cords is going to be same because they are made of same material. So T cos 30 into 2 is going to be equal to 3.924, which means we can find out the tension is, if I divide this with 2 into cosine of 30, gives us the tension of 2.2655. okay, the tension is 2.2655 newtons. And then the cross sectional area is the cross sectional area given, yeah, it's given 2 into 10 to the power negative 6, 2 into 10 to the power negative 6, and then the original length was 8 centimeters down and then 8 centimeters upwards, which means the unstretched length was 16 centimeters. And the change in length is actually 8 plus 8 plus 8 minus 16, right? So 24 minus 16 is going to be equal to 8. Okay, so if I put this in my calculator, into 16 divided by 2 into 10 to the power negative 6 into 8, I'm going to get 2265522, which is 2.26 into 10 to the power 6. okay, 2.26 into 10 to the power 6. The closest answer is option number C. So yeah, option number C is going to be the correct answer for question number 18. Let's look at question number 19. Which force extension graph shows plastic deformation of a sample of material? Okay, so force extension graph shows plastic deformation. Okay, basically we have been given the loading and unloading curve. If the loading and unloading curve are the same, which means that the body is elastic, right? It has loaded, come back to its original shape. Since there is no change in extension, option number A and B are going to be the wrong answer. In option number C as well, the extension has not changed, right? So we can say that it is not the correct answer because it is a plastic deformation. Okay, because the body has returned to its original shape. For option number D, the extension has changed, right? So basically the length has changed when the body is in rest, which means option number D is going to be the correct answer. For question number 20, okay, so the waves has now begun. Two waves pass through a point P. The graph shows the variation with time t of the displacement s of the two waves at point P. The graph shows the variation with time t, the variation with time t of the displacement s of the two waves at point P. Okay, so this is the displacement time graph, and two waves are passing through a point P. Okay, what is the phase difference between the two waves at point P? Okay, so we need to find out the phase difference. We know that phase difference is equal to change in displacement over the lambda into 360 degrees, right? Let's find out what is the shortest change in displacement. Let's find out the distance between consecutive crests. Okay, this is given to us as 1. The delta s is going to be 1, and the wavelength of this wave is from between this to this point, this is 11 minus 3, 10, 9, 8. Okay, so 1 divided by 8 into 360 degree gives us 360 is going to be divided by 8. 360 divided by 8 gives us 45 degrees. Okay, so for question number this, option number B is the correct answer. This formula is important. Okay, which row is correct for both progressive wave and progressive transverse wave and longitudinal wave? Correct for both of them, right? Transverse wave contains compression and rare fractions. Transverse wave this direction and this direction, right? No, transverse wave do not contain compression, right? They contain crest and trough. Transverse wave can be polarized, yeah, and longitudinal wave contain compression and rarefaction. So yeah, this is correct option. For question number 21, option number B is the correct answer. Okay, let's look at the other options as well. Vibrations are perpendicular, yeah. Can be polarized, no. Some can travel, no. Vibrations are perpendicular, no. Oh yeah, this for D number this is the correct option, but this is incorrect, so yeah, this is not the correct answer. Okay, option number B is the correct answer. Let's look at question number 22. Toy drone emits a sound of constant frequency 800 hertz. The speed of the sound in the air is 330. The drone moves along a straight path directly towards an observer and then continues in a straight line directly away from the observer. What is the velocity of the drone when the frequency of sound of the observer is 850 hertz? Okay, so you know, according to Doppler's effect, the observed frequency is equals to the observed frequency is greater, right? The observed frequency is greater whenever a body is moving towards, which means that 330, then 330 minus, okay, because the body is moving towards the observer, and then the frequency of the source is 800 hertz. We need to find out the velocity, right? If I put this in my calculator, 850 equals to 330 divided by 330 minus x into 800. If I solve this, I am going to get velocity as 19.41, which means roughly it's equal to 19 magnitude, and then direction is going to be towards the observer. Okay, option number C is going to be the correct answer for question number 22. Okay, let's look at question number 23. Which statement about the electromagnetic waves in a vacuum is correct? Let's look. Okay, basically radio wave, microwave, infrared, visible, ultraviolet, X-ray, and then gamma ray, right? So for this, 10 to the power -1 to 10 to the power 6 is the range. 10 to the power -3, 10 to the power -1, 10 to the power negative it's going to be till 700 nanometers to 10 to the power -3. For this, it's going to be 400 nanometers to 700 nanometers. The ultraviolet, I'm talking about the wavelength. Okay, the wavelength, this is something you need to memorize. Okay, this is not given in your data booklet, so this is you need to memorize. The ultraviolet light is going to be between 400 nanometers till 10 to the power -7, and then it's going to be 10 to the power -11 till 10 to the power -7, 10 to the power -13, 10 to the power -11, 10 to the power -13. These all are meters. Okay, so let's now look at the question. It will be easy whenever we have this table set up. Okay, infrared waves have shorter wavelength than visible light wave. Infrared waves have shorter wavelength. Infrared waves actually have longer wavelength than visible light rays. Okay, this is the wrong option for question number 23. Microwaves have longer wavelength than radio waves. Microwaves have longer wavelength than radio waves. This is also actually incorrect. Okay, ultraviolet waves have higher frequency than visible light wave. You know V equals to f lambda, and since velocity is constant, frequency is inversely proportional to wavelength. Okay, if wavelength is small, frequency is big. If frequency is small, wavelength is big. Okay, this is something you need to know, which means ultraviolet waves have a lower wavelength than visible light, which means they have higher frequency, right? So this is the correct option. Gamma rays have lower frequency than X-ray. Gamma rays have a lower wavelength, which means they are going to have higher frequency. Okay, this is the wrong option. Option number C is the correct answer. For question number 24. Okay, the distance between the, okay, let's read the question. Vertically polarized microwaves are emitted from a source. The microwaves are detected by a receiver that is connected to a cathode ray oscilloscope. The waveform displayed on the screen of the CRO has an amplitude of 2.6 centimeter. Sorry, the waveform displayed on the screen has an amplitude of 2.6 centimeter. Okay, the transmitted wave has an amplitude of 2.6 centimeter. Okay, this wavelength is 2.6 centimeter. The metal wire grid that acts as a polarizing, okay, wait a minute. The microwaves are detected by a receiver that is connected to a CRO. Vertical microwaves, the microwaves are detected by a receiver. The receiver is over here, right? And the waveform displayed on the screen of the CRO. Okay, so this is the transmitted. Yeah, the metal wire grid that acts as a polarizing filter is now placed. A metal wire grid that acts as a polarizing filter now placed between. Wait a minute then. So it's talking about the initial. Okay, don't be confused by the figure. Vertically polarized microwaves are emitted from a source. Okay, they are emitted, and then after there is a detector over here. So when this travels, initially there is no polarizing filter. Okay, so it is going to have an initial amplitude of 2.6 centimeters. So initial amplitude is 2.6 centimeters, not the final amplitude. Okay, Now a metal wire grid that acts as a polarizing filter is now placed between the source and the receiver. Okay, now the polarizing filter is there. The filter is oriented so that the plane of polarization is at an angle of 20 degrees to the vertical. The distance between the source and the receiver is unchanged. The settings to the CRO are also unchanged. What is now the amplitude of the waveform displayed on the screen of the CRO? Okay, so we know that intensity is directly proportional to amplitude square, right? Okay, which means that we can say that intensity is equal to Ka square, right? So what we can do is we can find out the new intensity, right? So for this one, what the intensity is going to be? Its intensity is going to be 2.6 square into K. Okay, so the value of K is going to be, I is going to be equal to 2.6 square, which means 6.76 K. Okay, 6.76 K. And now for this question, what is now the amplitude of the waveform displayed on the screen by the CRO? To solve this question, basically what we need to do is we need to find out that this K is going to be constant. Okay, we know that whenever there is a polarizing filter, we know that amplitude I equals to I naught cos square theta, right? I naught cos square theta. Since okay, so we did not have to do this all thing. Intensity, the original intensity is 6.76 K. So basically we can solve this question in a different way. Intensity is directly proportional to amplitude square. Since there is the ratio, the I over I naught is actually equal to cos square theta, right? Since intensity is directly proportional to amplitude square, we can write this down as Ka square over Ka naught square equals to cos square theta. The K and K are going to cancel out. This calculation was unnecessary. Okay, I'm sorry. Okay, so A square is going to be, the new amplitude square is going to be equals to A naught square into cos square theta. The new amplitude is going to be A naught times cos theta. Okay, so let's do this. The original amplitude was it was 2.6 centimeter. 2.6 into cos of 20 degrees gives us an answer of 2.44, which means 2.4 centimeters. So for question number 24, option number D is going to be the correct answer. Let's look at question 1. In an experiment, a stationary wave is formed on a string stretched horizontally between two fixed points. Which statement of our experiment is correct? Between the two, at certain times, the string between two nodes is horizontal with all points having zero displacement. A stationary wave is formed on a string stretched horizontally between two fixed points. Okay, which means that here is also going to be node and here is also going to be node, and there is a stationary wave, looks something like this. At certain times, the string between two nodes is horizontal with all points having zero displacement. Yeah, this is correct actually. Let's look at question number, option number B. Each point on the string between two antinodes has an oscillation of the same amplitude. This is going to be an antinode and this is going to be an antinode. Both of them have a phase difference of 180, right? Has an oscillation of the same amplitude. Between two antinodes, each point on the string between two antinodes has an oscillation of the same amplitude. Each point on the string between two antinodes has an oscillation of the same amplitude. This is actually incorrect because this is not going to be an ideal wave, right? Because this is not going to be an ideal wave. The number of nodes is equal to the number of antinodes. So 1 node, 2 node, 3 node, 4 node, 5 node, 6 node. There are 6 nodes in this figure, and 1 antinode, 2 antinode, 3 antinode, 4 antinode, 5 antinode, right? So you can see however setup you do, if the two nodes are like this, then there are the antinodes is always going to be less than nodes, right? This is also an incorrect option. Two adjacent antinodes oscillate in phase. This antinode and this antinode is going to oscillate out of phase. Okay, option number A is the correct answer. Some students might mistake in option number B because they are going to have the same amplitude whenever we are talking about the ideal wave. Okay, but since this wave is not ideal, we are doing it in the real world, right? Efficiency matters. Option number A is the always correct option. Okay, it might be always horizontal because this is going to be horizontal at some point. A musical organ produces notes by blowing air into a set of pipes that are open at one end and closed at the other. Okay, open at one end and closed at the other. The pipe looks something like this, which means the antinode is going to be here and node is going to be here, right? The speed of sound in the air in the pipe is this. What is the lowest frequency of the sound produced by a pipe of length 10 meters? Okay. It's talking about the fundamental frequency, right? Basically the length is given to us as 10 meters, and then between antinode and node the figure is going to look something like this. The lambda by 4 is going to be there, right? We know V equals to F lambda. V equals to F lambda. We have the V, we need to find the lambda, right? The lambda by 4 is given to us according to this question as 10 meters. Lambda is going to be equal to 40 centimeter, the maximum lambda, okay, which will help us to find out the minimum fundamental frequency. The velocity is 320 meter per second, 320, and the 40 into 10 to the power negative 2 to convert it into meters. Okay, we can find out the fundamental frequency like this. 320 divided by 40 into 10 to the power negative 2 gives us a fundamental frequency of wait a minute, did I make some mistake? V equals to F lambda. Speed of sound in the air in the pipe is 320 meter per second. For question number 26, I got the frequency to be 800 hertz, but it should be 8 hertz, right? So I think I made some mistake over here. 40 centimeter into 20. Okay, so it was given in the meter originally, so I did write meters over there, then it was given in meters, my bad. Okay, so 320 divided by 40 is actually equals to 8. Yeah, this is going to be the correct answer. Option number B is the correct answer for question number 27. In experiment, water waves in a ripple tank are incident on a gap S1. Some diffraction is about. What is changed to the experiment to provide a better demonstration of diffraction? Basically, diffraction is going to be the best whenever this lambda is going to be equal to this W, right? So we need to make sure that this lambda becomes somehow equal to W. Initially in this question what is happening is the lambda is less than W, right? Very less than W. So what we can do is either we can reduce W or we can increase the lambda. Okay, we can do either of the things. Increase the amplitude is not going to affect. Increase the frequency, we know V equals to F lambda. Since the V is constant, F is inversely proportional to lambda, right? If we increase the frequency, then the lambda is going to decrease, which is not the thing that we are intending to do, right? This is an incorrect option. Increase the wavelength of the waves. Increase the wavelength. Increasing the wavelength, yeah, this is something that we need to do. Yeah, this is the correct option. Let's look at option number D. Increase the width of the gap. The width of the gap needs to be decreased, right? So this is not the correct option, which means that option number C is going to be the correct answer. Let's look at question number 28. Light of wavelength lambda is emitted from 2 point sources, which could explain the zero intensity at P. The light intensity is 0. Light from the two sources is emitted 180 degree out of phase, and the path difference is half lambda. So basically whenever they are emitted in phase, the path difference should be 0. Okay, whenever they are in phase, the path difference should be 0, and out of phase the path difference should be the multiple of half lambda, right? This should be n lambda, and then after this will be even the multiple of lambda, or 0 or lambda or 2 lambda. This can be half lambda, 3 by 2 lambda, 5 by 2 lambda, like this. Okay, whenever the waves are in phase. Okay, light from the two sources emitted 180 degree out of phase, and the path difference is half lambda. The path difference is half lambda in the point P. Okay, so the light from the two sources at P, the light intensity is 0, right? Okay, so actually I meant the opposite thing. Okay, what I meant to say was, whenever the light is in phase, the intensity is going to be maximum over here, and whenever they are in out of phase, the intensity for it to be maximum. The thing is about intensity maximum. Okay, so the light intensity is 0 over here. Okay, which means that the opposite of this condition should be there, right? Which means that light from the two sources emitted 180 out of phase, and the path difference is half lambda. If this is happening, then this will be maximum intensity, right? This is incorrect. Light from the two sources is emitted in phase, okay, and the path difference is lambda. This will also lead to maximum intensity. Light from the two sources is emitted 190 degree out of phase. 90 degree is neither in phase nor out of phase. Okay, this is not incorrect. Correct option. Light from the two sources is emitted in phase. Okay, in phase, and the path difference is half lambda. Okay, so this is the correct. Okay, whenever it is in phase and it is half lambda, the intensity is not going to be maximum, it is going to be minimum, right? So this is the correct option. Option number D is the correct answer. Okay, let's look at question number 29. A beam of red light of wavelength 720 nanometer incident normal and diffraction grating and produces a diffraction pattern on a screen placed parallel. The beam of red light is replaced with the beam of illuminated wavelength which incident normal and same diffraction grating. In third order maximum, the illuminated wavelength is at the same position on the screen as the second order maximum. Okay. Okay, so let's find out what was the angle for the second order maximum for the red light. Okay. Did you understand the question? Basically, red light is incident normal and diffraction grating, and it produces a diffraction pattern. Okay, if red light was incident on a diffraction grating, it produced a diffraction pattern, right? And then now the red light is replaced with a beam of electromagnetic radiation of wavelength x. Okay, it might be some unknown light. Okay. Now what is happening is it's also incident, so the third order maximum for the wavelength x, the third order, okay, the third order is going to be equal to the second order maximum for the red light. Let's find out what was the angle for the second order. Okay, we know the formula for diffraction grating is d sine theta equals to n lambda. For red light, what was d? Okay, so d is not given and d is not even needed as well, and the sine theta is sine of theta is going to be equal to the n is going to be second order maximum for red light, and the wavelength is given as 720. We can find out that theta is basically the sine theta is going to be the constant for this question. Okay, this d sine theta is actually going to be constant because the d is not going to be changing of the diffraction grating, and the sine theta is not going to change because third order maxima is in the same position as the second order maximum, right? So for the light with wavelength x, d sine theta equals to n lambda, right? For that 3 into lambda is going to be equal to 2 into 720. Okay, I hope you how it happened, you understood this. So lambda is going to be equal to 90 into 2 equals to 180 nanometers. D sine theta equals to n lambda, right? Okay, third order maximum for the wavelength x is the same position as the second order maximum for the red light. Okay, so n was 2 and then it was 720. So okay, I wrote 270 over here, so it should be 720. Okay, so the lambda is now going to be 720 into 2 divided by 3 gives us 480 nanometers. Okay, so it's going to be 480 nanometer, which means option number A is the correct option for question number 29. Okay, for question number 30, it says what does the letter n represents in this equation? This is the formula. Number of charge carriers per unit area. For question number 30, charge carried per, this is wrong option, this is wrong option. Number of charge carriers per unit volume, yeah, this is the number density, right? Number of charge carriers per unit volume, this is the number density. So yeah, 30C is the correct answer. We need to find out the value of R. Okay, so the total power dissipated in the resistor network overall in this, the 24 watt is being dissipated. What is the value of R? Let's find out the total R for this circuit. Okay, it's going to be for this one it's going to be R by 2, and for this it's going to be, it's going to be 2R over here, 2R, and this is going to be R, and you know 1 by RT equals 1 by R1 plus 1 by R2, 2R plus R, 3R over 2R square, which means RT is going to be equal to 2R over 3, right? And then we know that the power is given to us, P equals to what do we need to find? We have the voltage V square by RT, which means that the RT is going to be equal to V square by P, 6 square by 24, and then the R is going to be 3 divided by 2 into 6 square by 24, 3 8s are 24, which means 36 needs to be divided by 16 gives us 2.25. Okay, which is basically 2.3 volts ohm. Option number D is the correct answer. For question number 32, which graph could show how the resistance of filament lamp varies with the applied potential difference is increased to normal operating potential difference. Okay, so you know that the graph for the filament lamp looks something like this, the IB graph. This is happening because as the voltage increases, the resistance increases, right? As the voltage increases, the resistance increases. Option number D is incorrect option because as the voltage increasing, it is showing that the resistance is decreasing. and then this is going to be incorrect because the resistance needs to change, and as the voltage increase, the resistance is going to be increasing, right? Initially it's going to increase at a linear rate. Just a minute. Okay, so I was saying that the IV graph looks something like this, right? Basically a more accurate IV graph is going to be let me just erase this. A more accurate IV graph is going to look something like this, where the x-axis and the y-axis, it's going to be constant for a certain period of time, and then after it's going to go like this, right? Which means that the resistance graphs will also follow some pattern, something like this. So option number A is not going to be the answer, option number B is going to be the answer, right? For question number 33, a piece of conducting putty is in the shape of a cylinder of length this and diameter this. What is the resistivity? You know, R equals to rho L by A, and then rho equals to RA over L, right? The resistance is given to us as 20. The cross-sectional area, we have pi d square by 4. Diameter is given to us, right? So cross-sectional area is going to be equal to pi d square over 4. So I can write over pi into 20. Let me just move this a little bit, okay? There is less space. Okay, it's going to 20 into 10 to the power negative 3 square divided by 4, and the length is 60 millimeter. 60 into 10 to the power negative 3. So we can put this in a calculator, and then we can find out 20 into pi into 20 into 10 to the power negative 3 square divided by 4 into 60 into 10 to the power negative 3 gives us an answer of 0.1 ohm meter. Okay, this is the answer. Yeah, this is the answer. Which statement about the electromotive force of a cell is always correct? EMF is the energy converted from electrical to other forms in the cell. EMF is the energy converted from electrical to other forms. This is actually not the correct definition, okay? Because convert electrical to other forms in the cell, not always in the cell. Basically it might be outside the cell as well, right? EMF is the energy provided by the cell per unit charge passing through it. Yeah, this is the definition of EMF as well. Energy provided cell per unit charge passing through it. This is the correct thing. The potential difference, EMF and potential difference are not the same thing, okay? EMF is the potential difference across the internal resistance. No. EMF is the potential difference across the terminals. This is also no, because there might be internal resistance as well, right? C and D, if they both points were combined, and then after it would have said that potential difference across the potential. Okay, this is not the correct option, and option number B is the correct option. Kirchhoff's first and second laws are consequences. First law is conservation of charge, and the second law is conservation of energy, right? For option number A is going to be the correct answer. For question number 36, a solid contains a cell of electromotive force E and internal resistance R. Why is the question is correct? Okay. You know that voltage equals to IR, right? Current is given to us as I, and the resistance is R plus R. So we can say that this is equals to IR plus I small r, right? E is going to be equal to. So can we say that E minus IR equals to IR, which means that option number A is going to be the correct option. For question number 37, which changes to R1 and R2 will increase the value of V out. Okay. So to increase the value of V out, we need to increase the V out is measuring the potential difference across resistor 1, right? Which means that we need to increase the voltage that is provided in resistance 1, which means that if this is increased, then for R2 it should be decreasing, right? The question says that product consists of two resistors of resistance R1 and R2 connected in series across a source of potential difference V. In the potential difference across R1 is V out. Okay, so we'll increase the value of V out. So if the R1 is doubled, R1 should be doubled and R2 should be half, right? So option number B is going to be the correct answer for question number question number 37. Option number B is the correct option. Let's look at question number 38. Two alpha particles with the same kinetic energy and are then deflected by a gold nucleus. Which diagram could show the path of the two alpha particles? Okay, so both of them are going to be deflected away. Okay, since this particle was nearer, which means that this is going to be deflected more. Okay, now let's look at in which option the first particle is being deflected more. Okay, it's not going to revolve something like this. This is not the correct option. In this, the first particle is deflected less. This is incorrect. It is not going to revolve something like that. This is deflected more, and then after this is deflected yes. So option number D is going to be the correct option. For question number 39. Which nuclide is found when this all goes beta decay? Okay, so carbon 610, when it goes beta positive decay, beta, it's going to be something like this. Beta positive has a charge of -1 and a mass of 0, right? Which means that the X particle is going to have 5 and 10 over here, right? So if you look at the periodic table, 5 is boron, right? Boron 510. So for question number 39, option number C is the correct option. Which is a possible quark composition of the hadron? A particular hadron is composed of 3 quarks and has a 0 charge. Okay, we need to get 0 charge, right? Down strange, you know that up, top and charm are +2/3 and down and strength. So this is not going to be the correct option, because down is -2/3, sorry, -1/3, and down is -1/3 and strength is -1/3 as well. So this is going to be equal to -1, right? Up, down and strength. Up equals +2/3, down equals -1/3, strength equals -1/3. So yeah, this might be the correct answer, right? Up, down, +2/3, +2/3, -1/3. No, up and strength, this is not either. So option number B is the correct answer, right? Okay, so this is the total paper which we have solved in 1 hour and 5 minutes, including the explanation, right? So yeah, we have solved this in proper timing. If you do it in proper time, then you can solve it in maybe like 40 to 50 minutes. Okay, it's not that hard paper. Okay, so yeah, thank you so much for watching, and we will come with next paper 1 2 very soon.